y'all. Welcome to my course. This is Factoring Basics, and I am Mrs. Aja Simmons. I just wanted to do a quick welcome video for you just to give you an idea of what's going on. I decided to create this course because I am an instructor that teaches college algebra, and one thing that I see that students fall short in is factoring. You have to have a strong foundation in factoring in order to make it through college algebra because it shows up in every single section, every chapter. I mean, just when you thought you'd gotten away from it, here it comes again, factoring. So it's one of those things that always kind of haunts you in college algebra and even in further mathematics. So I felt like I needed to create a course just to go through some of the factoring basics and make people feel more comfortable with factoring. I'm talking about factoring for 2 terms, 3 terms, and 4 terms. And if you don't understand what that means, trust me, just stay tuned, okay? So before we get started, I wanted to give you a little heads up. There should be a PDF in this course that I would suggest you either print out or download and have it in your possession somewhere. The PDF is called Factoring Basics. It's right here on my computer, just so I remember the name of it, but it's called Factoring Basics. So print that document out, or like I said, have access to it so you can write on it and follow along with the lessons that you go through in this course. So I think that will be helpful because at the end, you will have a document that you can refer back to. If you need to go back and I can't quite remember how to do this, let me go back and look at it. You'll have the document in your hand for you to do, go back and reference. So I just wanted to say that, and I don't want to ramble too much because you paid for a course. So let's go ahead and get started with the first lesson in basic factoring. Okay, as I'm looking at the document, if you look on the very first page of your PDF, what you see on the first page is the factoring strategies. So this is basically everything you're going to learn in the course. I'm going to break it down further, but I wanted you to see the overall picture. So on the first page of the PDF, you see a series of steps. This is like my factoring strategies, right? So just quickly going through these steps. The first thing you do in factoring is find the GCF. Then you count the terms. And depending on how many terms you have, either 2, 3, or 4, then you would do a certain technique. After you count your terms, you factor, depending on the technique that you choose. And then you look and see if your polynomial can be factored even further. And then the last thing you do is you check, okay? So everything that we're gonna learn is on this first page, just so you can see the overall scope of what we're doing. And as I'm going through this lesson, I'm just gonna go through each one of the steps and show several examples, a couple of special cases, so you feel more comfortable and familiar with each one of the steps. And I think at the end, let's wrap back around to this first page to make sure we understand what's going on, okay? Okay, taking a look at the first step. So no matter how big or small your polynomial is, the very first step in factoring is to look for a GCF. GCF stands for greatest common factor. No matter how big or how small the polynomial is, you have to look for a GCF first before you even start the problem. So you look at each one of the terms and see what they have in common. Let's look at some examples. Okay, first step in factoring is to look for a greatest common factor. You're looking for the greatest common factor. And I made 2 notes here. I said, first you want to look for a GCF among the numbers, and then you want to look for a GCF among the variables, the letters. If you break this down one at a time and not look at it as a whole, then it makes it a little easier. So let me put an example up here. Let's say I have 8, a to the third, and then b to the third, plus 12 4a squared b. Okay? So this is my polynomial, and they're asking me to factor it. Now, the first step in factoring is to take out a GCF. So I look at this polynomial, and I'm looking for a GCF. Let's just look at the numbers first. So if you look at the numbers, you have a number here, you have a number here. You're looking for the highest number that divides evenly into both of these numbers. So think about the numbers that go evenly into 8, and think about the numbers that go evenly into 12. You're looking for the highest number that can go into both. So you may start with 2. Yeah, 2 goes into 8, it goes into 12, but there's a number higher. That would be 4. 4 goes into 8 and 4 goes into 12 evenly. Okay, so that's considered to be the GCF. Now let's look at the letters. Let's look at the variables. So we're going to look at the variables one at a time. So let's start with a. I have a to the third and a squared. Now you're looking for the greatest common factor. You're looking for how many a's do they have in common. And when you think about how many a's they have in common, they only have 2 in common. So you put a squared. Okay, so GCF is kind of confusing because greatest common factor, a lot of times students think you're looking for the greatest number. No, you're looking for how many do they have in common when it comes to variables. Another way to think about it is you have a to the third, right? And then you have a squared. Okay, a to the third is the same as saying a times a times a, right? And a squared is the same thing as saying a times a. Now they're asking you, what is the GCF? If you're looking for the GCF, right, you're trying to figure out how many do they have in common. They have 1 in common. They have 2 in common. That's why I put a squared. So kind of think about it like that when you're looking for a GCF with variables. That's usually kind of helpful. So let's look at b, right? Let's look at the next variable. Let's look at b to the third, and then I have b. How many b's do I have in common? I only have 1 b in common, so that's going to be my GCF. Okay? You have b to the third and you have b. They only have 1 b in common, so that's considered to be your GCF. So 4a squared b is considered to be the GCF. Now you have to write what you have left inside the parentheses. This is kind of like a reverse distributive property almost. So I got to write what I have left. I took out a 4. What's 8 divided by 4? That's going to give you 2. And then you took out 2 a's because you have a squared. How many a's do you have left inside the parentheses? You just have 1. You took out 1 b, but you had 3 b's inside. So how many b's are left inside the parentheses? B squared. You see? And then I put my plus sign, and let's write what we have for the next term. 12 divided by 4 is going to give you 3. You took out 2 a's, and you had 2 a's, so you don't have any more left. So I don't put anything there for a. And then you took out 1 b, you had 1 b, so I don't put anything there for the b either. So this is complete. A quick way to check yourself is just distribute in your head real quick. Take this term and distribute here and distribute here and see if you get the same thing back. So this will be 8, a to the third, b to the third, plus 4 times 3 is 12, a squared, b. Let's look at some more examples. Let's say I have 9 a to the fourth, b to the third, plus 27 a to the third, b to the fourth, minus 18 a squared b to the fifth. Okay, let's say this is the polynomial and they're asking you to factor. The directions will say factor or maybe take out the GCF. So I need to factor this. What are we going to do first? We're going to look at the numbers. Let's just look at the numbers. Ignore all the variables for right now. We just want to focus on the numbers. I have 9, I have 27, I have 18. What is the highest number that I can divide into all three of these numbers? It has to be the same number. That number is going to be 9. I can take 9 divided by 9. I can take 27 divided by 9. I can do 18 divided by 9. All of those have 9. So that's going to be considered the GCF among the numbers. 9. Now let's look at our variables. One at a time. Let's just look at A. And as you're working through your handout, you can underline the variables just like I'm doing. Underline all the A's so your mind can just focus on A. So I have A to the fourth, A to the third, A squared. How many do they have in common, right? Think about how I did that little chart, right? A to the fourth is the same thing as saying A times A times A times A. A to the third is the same thing as saying A times A times A. A squared is the same thing as saying A times A. Now let's see how many they have in common. And that will tell you what the GCF is going to be. So that's 1 they have in common. Here's 2 they have in common. They don't have any more in common. Even though these first 2 right here, these are in common, but it's not in the third one. So I can't include that. It has to be among all 3, right? So they only have 2 in common. That's going to be our GCF, A squared. And then I got to remember what I have left over when I do the parentheses. Okay, let's do the same thing for B. Let me erase this. Yada, 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 yada. Go away, go away, go away, go away. So let's look at our B. So B is going to be, I can actually make this a different color. How about that? Let's make this blue. Okay. So I have B, B, B. So I have B to the third, B to the fourth, B to the fifth. How many do they have in common? It's always going to be like the lowest exponent. That would be a quick way to look at it, right? B to the third is going to be your GCF. That's how many they have in common. So what I have created here is the GCF for the whole polynomial. 9a squared b to the third. Now I got to write what I have left in the parentheses once I take out that GCF. So 9 divided by 9 for the first term. 9 divided by 9, that's 1. So I don't have a number. I already took 9 out. I have a to the fourth, but I took a squared out. That's going to leave me with 2 a's. I have b to the third, but I have b third as my GCF, so I already took b to the third out. I don't have to put anything else there. So that's done. Let's go to the next term. 27 divided by 9. 27 divided by 9 is 3. Then I have a to the third, but I took 2 a's out. I have 1 a left. I have b to the fourth, but I took 3 b's out. I have 1 b left. Boom. Now I go to the next term. I put a subtraction sign. 18 divided by 9 is 2. And then I have a squared, but I took 2 a's out. Done. I have b to the fifth, but I took 3 b's out. How many b's do I have left? 2. So this would be your statement. And if you want to, you can just you don't have to write this out completely, but when I'm factoring, when I'm taking out a GCF, I always mentally go back and make sure it makes sense, right? So 9a squared, b to the third, that's going to give me 9a to the fourth, b to the third. I know when I multiply those, I get that first term. Then I go to the next term. 9 times 3 is 27. A squared times A is A to the third. And then B to the third times B is B to the fourth. And then the last term is minus 18 A squared. And then I have B to the fifth. So it all checks out. Okay, let's look at another example. So one thing that I want to make sure you understand when it comes to taking out a GCF, like let's look at an example like this. Let's say negative 12 x to the third y minus 6 x squared y plus 3 xy. So one thing I want to make note of, and a lot of times it's not brought up until it happens, but if you start practicing now, it will help. So when you're taking out a GCF, you always want your first term inside the parentheses to be positive. Okay, so if you notice on this problem right here, they're telling you to factor. That means you take out a GCF, take out the common numbers, common variables. But also, you want to notice that this first term is negative. So if you have your first term being negative, when you take out your GCF, you need to also take out a negative sign, so we cannot have that negative in front of our polynomial. So let me show you what I mean by that. So we're going to look for the GCF, right? We're going to look for the GCF among the numbers. Let's look at 12, 6, 3. So we're looking for the greatest number that can divide evenly into all three of these numbers. And that's going to be 3. Okay, so I put a 3 here. But instead of it being just a 3, I'm actually going to make it a negative 3. And the reason why I'm doing that is because now that first term won't be negative. And I'll show you what I mean by that when we do the stuff inside the parentheses. So I'm factoring out a 3 and I'm also factoring out a negative. Let's look at our variables. Let's look at x. So x to the third, x squared, and x, they all have an x in common. Just one x in common. Let's look at our y's. And all of them are y. So they just have one y in common. Good, that makes it simple. All right, now let's look inside our parentheses. So if I do negative 12, think negative 12 divided by negative 3. A negative divided by negative is going to be a positive. So that first term is going to turn into a positive 4 because you factored out a negative. You took out a 3 and you also took out a negative. So that made it a positive 4. What do you have left for the variables? You took out 1x, so you're left with 2. And then you took out 1y, you don't have any left. Let's look at the next term. You have negative 6 divided by negative 3. A negative divided by negative. Again, negative 6 divided by negative 3 is positive 2. So that's going to turn into a 2. What do we have left with our variables? You took out 1x, you're left with 1. And then you took out 1y. You don't have any y's left. And then last, you have 3, a positive 3, divided by a negative 3. A positive divided by a negative is still going to be a negative. So that's going to give you negative 1, basically. You don't have to put the 1, but you could put negative 1. And then as far as your variables go, x and y, you took both the x and y out, so you actually need that 1 there. And then we close parentheses. So notice what happened here. And this can be kind of confusing when you're trying to learn this, but we had to factor out a negative. And what happens is each one of the terms, the signs change. You see, the first term was negative, now it's positive. Let me show you here. The first one was negative here, and now it's positive. The second term was negative, now it's positive. The last one was positive. Now it's negative. So when you take out a negative sign, it switches the sign of everything in your polynomial. It's pretty cool. So I feel like I need to do another example. Let's see if I have room on here to do one more example. Yeah, I can do it right here. So let me do another example. Let's say I have, looking in my book here, negative 12 x to the fourth plus 36 x squared. And I'm asked to take out the GCF, or I'm asked to factor. The directions will probably say factor. And so your first step in factoring is to take out a GCF. So you are looking for a GCF among your numbers. Look at 12 and look at 36. What's the highest number I can divide 12 and 36? I can divide into 12 and 36. That will be 12. 12 is the highest number because 12 goes into 12 and 12 also goes into 36. But look what I have here, a negative. So instead of it just being negative, I actually need to take out a negative 12. Instead of it just being 12, I need to actually take out a negative 12. Sorry about that. And then let's look at our variables. I have x to the fourth, x squared. They only have two x's in common. So this is my GCF, negative 12x squared. And let's see what happens inside my parentheses. I took out a negative 12. Negative 12 divided by negative 12 is going to be 1. So I can put a 1 there just in case I need it. And then I had x to the fourth. I took out two x's. That left me with two x's still inside. So I don't necessarily need that 1 there. I'll keep it there for right now. And now let's do 36 divided by negative 12. That's going to be negative 3. 36 divided by negative 12 is negative 3. And then I had two x's. I took 2 out. I don't have any more left inside. So right here, this is my factored polynomial. I don't necessarily need this 1 in the front because it's understood. And then this will be my final answer. You can distribute to see the original problem. Okay, your next step, once you take out the GCF, the next step is to count how many terms you have. Now, terms are separated by plus or minus, okay? So depending on how many terms you have is going to determine what technique you use. In this course, we're only talking about polynomials that have 2 terms, 3 terms, or 4 terms. So let's make sure you understand how to count your terms. This will be very quick. The next step, once you take out a GCF, is to count your terms. So I just want to make sure you understand what I mean when I say terms. Like if you saw something like this, this has 2 terms in it. I stated before that terms are separated by plus or minus. There's a plus sign here. So this would be considered a term. This would be considered a term. So let's say if we saw something like this. (15xy plus 9x squared y to the third). So remember, terms are separated by plus or minus, right? So this would be considered a term. That's 1. This is a term. That's 2. This is a term. That's 3. Okay, so this one has 3 terms. Okay, this one had 2 terms. I didn't put that down, so let me be consistent. All right, and then let's say if we had something like this. I got A and A, B, and X. I'm completely making up stuff. But even here, none of the variables really match or anything like that, but it's all good. I'm looking for my plus or minuses. I have 1 here. I have 2. I have 3. And then I have 4. So this one, because of the plus or minuses that are here, I have 4 terms. Okay, and it's just important that you understand how to count your terms, because if you know how many terms you have, then you know what approach you can take. Okay, you also, you can't factor anything like this, but just making up something. So let's say if you have something like this, how many terms do you have for something like this? There's no plus or minus. This is just one term. Okay, can't really factor one term, but I just wanted to show you that it's the plus or minuses that really separate your terms out. So this just has one term. What we're going to focus on is things that have 2 terms, 3 terms, and 4 terms. So make sure that you're able to count your terms.